So what are the things that we completed? So measure of central tendency we completed, measure of dispersions we have completed, outliers, all the things we have completed. Let's go with the inferential statistics. In the descriptive statistics, you see standard deviation, variances we completed, normal distribution also we completed. Okay. So today what I will do is, so let me connect. Okay. So after connecting, let me import the packages. So let me import the packages. We have seen all the outliers concept, how to handle the outliers. See how to handle the outliers. All these concepts we have seen very clearly. We have seen very clearly stats, and also see normal distribution also we have done. Normal distribution also we have done in the last section. Basically, normal distribution is also called as Gaussian distribution. Few people will call this as a Gaussian distribution. Okay, so there are two different names for it. You can call them as normal distribution, or you can call them as Gaussian distribution. Gaussian distribution. Gaussian distribution. Okay, fine. So these are the topics which comes under analytics people for the descriptive statistics. Let's say we'll go with the inferential statistics. Inferential statistics. Inferential statistics. So, what is the purpose of this inferential statistics? What is the purpose of this inferential statistics? Let's say, see, inferential statistics, as I mentioned, based on the sample data, analyzing the population data. Based on the sample data, analyzing the population data. Very simple. Very simple. So here in this concept, we need to learn two things. Only two things, but very important. That is covariance, and the second one is correlation. So first one is covariance, and the second one is correlation. What is happening here? Okay. So covariance and correlation. So here, what I want to do is, let's say, first we'll learn about covariance. First we'll learn about covariance. What is the meaning of covariance? Covariance is nothing but, which is used to say, let me discuss about covariance. Suppose if you have two columns. So if you have two columns, let's say if you have two columns, so it is going to tell you. So covariance, what it will tell you? It will tell you the relation. It will tell you the relation between two columns, relationship between the two columns. For example, imagine if I have a column X and a column Y. For example, a column X and a column Y. So X1, 4, 9, 7, 3, 2. Suppose this is the data which is present inside the X column. So 4, let's say. So 2, 4, 6, 8, 10 or 12, something like that. Something I'm taking. So suppose this is the data I'm taking. Suppose this is the data I'm taking. So if you take x-axis, okay, and if you take y-axis, and if you mark the points, let's say in the x column, what is the maximum value? Is 9. So starting from origin, it starts from origin 1, 2, 3, 4, 5, 6, 7, 8, 9 till 9. Let's say in the y, we'll start from, what is the maximum value? Maximum value is 12. So start from 1, 2, 3, 4, so on till 12. So mark the points on the axis. Mark the points on the axes. Okay, mark the points on the axes. When x-axis 1, y-axis 2. So when x-axis 1, y-axis 2 means the point will come here. The point will come here. When x-axis 4, y-axis 4, the point will come here. Okay, 9 and 6. Suppose x-axis 9, suppose 6 will be here. Just to make the points, okay, take the value 7, 8 means somewhere 7 and the 8 will be somewhere. So instead of here, let me take the point and mark it here. So just take the data and mark it here. So 310 means suppose 310 will be somewhere here. 212 means 212 somewhere here. Guys, if you see here, whenever the x value is increasing, see, you need to find the relation. Covariance means which is used to find the relation between these two columns. Which is used to find the relation between these two columns. So if anybody asks you what is the relation between these two columns, you see guys, whenever the x values are increasing, the y is increasing or not? Is there any decreasing value? For example, 1 is increasing to 4, 2 is increasing to 4, yes or no? So whenever the x value is increasing, the y value is increasing or not? Yes or no? So when x is increasing, see, when x values are increasing, the y is increasing. So this is known as an positive relation between the two columns. Positive covariance, which means positive relation between these two columns. Positive relation between these two columns. So when x is increasing, suppose y is decreasing. Now tell me guys, is it positive or it will be negative? Do it will be positive or do it will be negative? When x
Negative.
values are in, yes, it will be negative relation. It will be negative covariance. Why? Because if x is increasing, but y are coming down, so it is negative completely. It is negative completely. So when x is decreasing, y is increasing. Now tell me,
Negative.
Negative
negative,
only, sir.
negative. So when x is decreasing, y is decreasing. Now
Positive.
Positive.
it will be it will be positive covariance. So very simple. What is the meaning of covariance? Covariance is nothing but which is used to find out the relation between two different columns. Relation between two different columns. For example, and you need to understand one thing, covariance concept only works with numerical columns. For the categorical columns, can you do these things, guys? It only works with numerical columns. Point number two. Point number two here is what is the range? Range. What is the range of covariance? The range of the covariance. The range of the covariance is 0 to last one. I'm just taking sample. Okay, Shravani, I'm just taking the sample data just randomly. Understand the concept. Okay, just I'm telling like when x is increasing, y is if the x values are increasing, and if the y is increasing, means it will be positive, something like that. Okay, what is the range of the covariance? The range of the covariance is nothing but 0 to infinity. 0 to infinity. So which means, sorry, my bad. Minus infinity to infinity. Minus infinity to infinity. Which means if you do the calculation and if you get a negative value, the relation between the two columns will be negative. For example, what is the formula? What is the covariance formula for the sample data? Covariance formula for the sample data, because we need to find out for the sample data only. There is no need of population data here, I'm telling you, because nobody gives you the population data here. What is the formula for sample data? X minus x bar into y minus y bar divided by x minus x bar into y minus y bar divided by n minus 1. N minus 1. This is the formula for the covariance. This is the formula for the covariance. So what you do is you have two different columns. You have two different columns. Implement these values on top of this formula. You will be getting a value. So if your value is a positive value, then it is a positive relation. If the value is a negative value, then it is a negative relation. So how you will implement? You have the x data. You have the x data. For example, I'm writing here. So what you have the x data here. What is meaning of X bar, guys? What is the mean of X bar? X bar means what?
Mean.
Mean.
Mean
Nothing
value.
but mean of X. Y bar means is nothing but mean of
Mean of
Y. Mean of Y.
Y.
Okay. So suppose what is the mean? Somewhere. Suppose imagine I'm just taking sample randomly. Suppose if my mean is suppose 4. If my mean is 2, for example, I'm telling. Then how you will do it? So X means each and every data point summation will be the summation of I is equals to 1 to n. Each and every data point 1 minus 4 plus 4 minus 4 plus 9 minus 4 plus 7 minus 4 plus 3 minus 4 plus 2 minus 4. 2 minus 4 into y minus y bar. Y minus y bar, which means 2 minus 2 plus 4 minus 2 plus 6 minus 2 plus 8 minus 2 plus 10 minus 2 plus 12 minus 2. 12 minus 2. Okay. Divided by n minus 1. What is the meaning of n minus 1? What is the meaning of n minus 1? Number of rows, number of values 1, 2, 3, 4, 5, 6. 6 minus 1 will be 5. So if you do the math calculation, so what you will get? You will get a value. Whatever the value that you are getting here, if it is a positive value you are getting means it is a positive relation. If you are getting a negative value means it is a negative relation. Simple. Negative relation. Yes, you understood what is the meaning of covariance? Covariance means which is used to find the relationship between the two columns. Which is used to find the relationship between two columns. The range is minus infinity to infinity, which means you can get any value in the positive side. You can get any value towards negative side. So if it is a positive value, positive relation. If it is a negative value, negative relation. So how the positives and negatives will be divided, I mentioned here clear. Understood, guys?
Sir, could you please explain that calculation whichever you did?
This calculation, very simple.
Yes.
X minus X bar, whatever the data that is present in the X, 1 minus X bar, its mean, 1 minus mean, plus 4 minus mean, plus 9 minus its mean, plus 7 minus its mean, plus 3 minus its mean, 2 minus its mean. X minus X bar, X values, difference between its mean. Okay? Into
Okay.
Y minus Y bar. Clear
So
now,
X
guys?
bar means mean only.
Sorry?
X bar means it's mean only.
X bar means
Mean.
X mean. Y bar
Oh,
means Y column mean. Now,
okay.
so to implement this process, let's do one thing. Let's upload any data set. Let me upload any data set, any one of the data set like a Titanic data set or anything. Okay. So I'm going to load that Excel sheet here. I'm going to load that Excel sheet. So df is equals to pd dot read underscore csv. So which means Titanic. What is the name of the file exactly? What is the name of the file? Titanic hyphen dataset dot csv. Titanic set dot csv. Okay, I'm reading the data and I'm going to show the data in front of. So I think, see, this is the data set. So this is the data set Excel sheet data which is present inside the Titanic data set. Now my question for you is, covariance will be applied only on the numerical data or in the categorical data, guys?
Numerical data.
Yes. Covariance will be applied only on
Numerical.
numerical data. So Guys, you do one thing. Do one operation in pandas and separate only numerical data. So you have the data set right here. You have the data set here. So from this data set, what I'm asking is you only need to pull out the numerical columns and keep it in one variable and keep it in one variable. Let's say, for example, numerical numerical columns. Okay, numerical columns is equals to. So from this data is present in which variable? The variable df. The variable df. So df in the df in the df variable, I want to select df means all the data. So in the entire data, I want to select the columns. Data type means I want to select the columns. So you want the numerical columns or you don't want the numerical columns, guys? You
We
don't
want
want the numerical. Yes, we don't want the numerical columns. So you don't want sorry, you don't want categorical columns, right? You only need numerical. So exclude. Use exclude. I don't want to include. I want to exclude. I want to remove object. Object means what? For example, df.info. If you use df.info, you see here whatever for the categorical columns. If you see, let's say here df.info. I will be using the parentheses. See here for the categorical columns. For the categorical columns, let's say embarked or anything, it is showing object. What is the meaning of objects? Object means it is a categorical column. So what I'm doing in the entire data, I'm going to select the data types, and I want to remove. Exclude means I want to remove the categorical columns. If I remove the categorical columns, remaining things will be numerical only, no?
yes, sir.
Guys,
Yes.
remaining things will be numerical only. So I'm going to execute this one. I'm going to execute. So in the if I print the numerical columns in front of you, if I just print the numerical columns in front of you, see all the columns which are numerical will be showing in front of you. See only the numerical columns. Okay. Now if I apply covariance, see how you will apply covariance. See one column for the passenger ID with the survived column, I will find the covariance. For the passenger ID with the pre-class, I will find the covariance. For the passenger ID with the age, I will find the covariance. For passenger ID with SIVSP, I will find. So each column with remaining other columns, I will be doing the covariance. For example, I want to do the covariance between survived column and age column. So survived will be treated like X and age will be treated like Y. Please implement in that particular formula which I mentioned, you will be getting the covariance value. Suppose if I want to do the covariance between survived and fair, treat this as Y, this as X, remaining every concept is same. Remaining every concept is same. So now see here what I'm going to do is the numerical columns, which means the data which is present. Numerical column means all this data. On top of all this data, I want to apply okay covariance. Simple COV. I want to apply covariance. See, covariance is applying all this mathematics. All the mathematics within nanoseconds, it is going to show in front of it. That is the power of Python. See, see guys, the relation between you and yourself will be 100%. Yes or no? Sir, no, guys. Me
Yes, sir.
with myself, it will be 100%. So there is no need of checking with itself. It's logicless. Okay, so with itself, no need. So passenger ID, how it is the relationship with the survived column? See, it is a negative covariance. Yes or no? Negative relation is there between these two columns. Negative. But age and passenger ID positive relation is there. Negative relation, and with fair also positive relation is there. Again, survived column with other columns. See, by looking into the values, you can see, you can find out by looking into the by checking the values, you can see. Guys, understood?
Yes,
Understood, guys? Clear now, everyone? What is the meaning of covariance?
yes, sir.
So the next one, which is a very powerful one, very important one. That is correlation. Guys, see here, simple logic. Covariance is giving you Covariance is giving you the relationship between two columns. Yes or no? The relationship between two columns it is giving you. Okay, that is accepted. My point is, you are not giving me the confidence. Let's say, what is the meaning of confidence means the relationship between the age column and the passenger ID column is positive. Fine. Out of 100 percentage, how much? You need to give some value, no? Yes or no?
Yes, sir.
So you are just telling it's a positive value. It's a positive means what? It's a positive, but how much positive? 10% positive, 20% positive, 100% positive, 90% positive. How? Those things will be done with the help of correlation. Those things will be done with the help of correlation. What is the meaning of correlation? Correlation is nothing but which is used to find the relation the relation between columns the relation between the columns and strength also so what I'm saying is in between two columns it is not only going to find the relation whether positive or negative, it will also find out the strength, how much relation it is, 80 percentage, 85, 90 out of 100, how much percentage. So it will clearly tell you. It will clearly tell you. Not only finding the relationship, but also it will find out the strength. But also it will find out the strength. So basically, correlation can be done with two different techniques. So basically, the correlation can be done with the help of two different mathematics. With the two different mathematics, you can do it. One is one is Pearson correlation. One is Pearson correlation. One is Spearman Spearman correlation. Okay. Pearson correlation is there are two different mathematics to implement the correlation concept. One is Pearson correlation, one is Spearman correlation. Okay, correlation means nothing but we can find the relation between the columns and we can also find the strength between the columns. We can find the strength between the columns. So what is the range of the correlation? The range of the correlation will be minus 1 to 1. Most interview point question. Minus 1 to 1. What is the meaning of it? For example, if there is a x column, if there is a y column, for example, like 1, 2, 4, 9, 7, some data is there in the x. 10, 14, 7, 9, 2. Some data is there in the y. If you find out the correlation, if you find out the correlation between these two columns, either using the Pearson correlation or using the Spearman correlation mathematics, any one of the mathematics doesn't matter. If you use any mathematics comes under correlation on top of these two columns, on top of these two columns, if you are getting a value, if you are getting a value from minus 1 to 0 means from minus 1 to 0 means it is a it is a negative relation. It is in a negative relation. So these two columns are completely negative. They are not depending on anything. They are completely negative. So if completely 0 means, if it is showing 0 means nothing. So there is no comparison. There is no relation at all. There is no relation at all. If we get any value between 0 to 1, it is a positive relation. It is a positive relation. For example, I find out the relation between these two columns and I got a value. I got a value of 0.4. So out of 0.4 means it is a 0.4 comes under which category? Either do it comes under this category or do it comes under this category or do it comes under this category? Tell me which category it belongs to? It belongs to 0 to 1. 0 to 1 means what? Positive or negative? It is a
Positive.
positive. So the relationship between these two columns is positive. And how much percentage it is positive? Out of 100 percentage, 40 percentage it is positive. Understood, guys? Strength also we are going to find out. How, sir, how you are saying for 40? 0.4 means nothing but 40 only, no? I mean, if you multiply into 100, it will convert 40. Okay? Understood, guys? Simple logic. What is the purpose of using correlation? Basically, correlation is one of the most important concepts which we will be implementing mainly in the machine learning. Which we will be implementing in the machine learning. I don't know how many of you are aware of it. Let's say, for example, in the real time, in the real time, guys, did I teach you about GitHub?
No.
I didn't teach you about GitHub, guys, still now?
No, sir.
Oh, my bad. Okay, I will discuss about it also. 1 minute, sir. We have to find both covariance and correlation. If yes, then we have to do it in the same way in the real time. No, no, Priyanka, I will tell you how to do it. So see, let's say, for example, what we are discussing. So what is the purpose of using correlation mainly? So the purpose of using this correlation mainly is, for example, if you have the data, see, for example, we do one thing. The purpose of using correlation is in the real time, suppose you got a data, and in that particular data, suppose you are having 1,000 columns, guys. Understand my question very clearly. 1564218. Okay, so what I'm asking is, imagine in the real time you got a data where the number of rows are 1 lakh. 1 lakh rows are there and 1,000 columns are there. So directly you will work on the data. You tell me. Directly will you work on the data?
No.
So 1,000 columns means, guys, imagine according to the NumPy, 1,000 columns means 1,000 dimensions. Every column will be converted like, see, one column means x-axis, yes or no?
Yes.
X, Y, coordinate axis, one other axis. 1,000 columns means it's a terrific, very, very terrific. So we can't build ML models definitely. Machine learning algorithms, it will be very, very, very complicated. Okay.
Yes, sir.
So we need to reduce the columns. So the columns which are completely unimportant, the columns which are completely unimportant, those kind of columns we need to remove. So to remove those kind of columns, definitely there is only one and only option. Okay, there are 2 to 3 different ways, but out of that, the most powerful one and used one is nothing but correlation. So let's say we will be using using the correlations, we can remove the unwanted columns. We can remove the unwanted columns for sure. For sure. How? How we can remove the unwanted columns? Let's see. See, I will be showing you. I will be showing you how. See, if you have 1,000 columns, unwanted columns might be 300 to 400 columns. See, you are having 109 columns. Initially, you have 109 columns in the data. But at the end, after doing some operations, how many I'm having, guys? How many I'm having? 74. So, almost 30 columns I am removing. 30 columns I am removing using the feature selection concept. Which means the correlation concept. So it is also one of the main pipeline for every data scientist. You can see a feature selection, which means the correlation. See here, the correlation is one of the most important pipeline for every data scientist. So I will give you one best example. I will give you one best example. See, there is a 2 columns. So imagine there is a column X, column Y. 2 columns are there, for example. You can give any names for this. Just I'm writing X and Y. Just I'm writing X and Y. So imagine we have two columns. So I want to find out whether these two columns is important or not. Okay? Whether these two columns are important or not. Or out of these two columns, out of these two columns, at least one is important or not. How we can do it? How we can do it? So simply, I will give you one example. Imagine this column is one of the person. Let's say this column is one of the person, for example. Okay, treat two columns as a two persons, and imagine this both the people are friends. This both the people are friends. So if they went to the bank and if they rob anything, so if they rob the money or anything from the bank, and one person after taking the money from the bank, he went to UK and another person went to USA. So now tell me, police will be in search for one person or police will be in search for both the persons?
Both the persons.
Both the persons. So in that case, if I, let's say these both are friends, both of them went to the bank and they got the money. They went to, one person went to UK and one person went to USA. Imagine, why to waste my time? I will send only few people to target this one person, because if I find this person, he is his friend only. I can find out this one. Yes or no?
Yes, sir.
So because they have the relationship, because they have the relationship. Imagine same example, they both are not the friends. This person went to one bank and robbed the money. This person went to some other bank and robbed the money. They have no relation. The police need to catch both the people individually. So in the same way, imagine in a data set, if you have multiple columns, if you have multiple columns, suppose if you have this kind of columns, so the first column and the second column, first column and the second column, I will find the relation, whether it is a positive or not. Positive or not. If it is a negative means the relation between these two columns is negative means we should not do anything. If it is negative relation means one column is not depending upon another column. Okay, negative. So every column is unique. So we need to keep the two columns as it is. No relation means also we need to keep that columns as it is. But the relation between these two is positive and you are getting almost 90 percentage. The positivity, I mean the strength also coming 90 percentage. Now tell me the relation between these two columns is positive and 90 percentage of the information between these two columns are same. In that case, can I remove one column and I keep one column? No, because 90 percentage of the information between two columns are same. So I can remove one column and I can maintain another column. Am I right? Yes or no?
Don't know, sir.
Because we can we can remove one column and we can
No,
keep
no,
next one column.
no, no. If
Why?
if we keep one column means 10% of data we are missing. Nothing.
We are missing the 10% of the data.
Mm.
90% of the information is maintaining, but you are removing one dimension now. Imagine if you are removing one dimension means how much CPU consumption will be safe side. Okay, so we need to think in application manner. If you want to run the applications, huge dimensions are not so possible. Okay, so you will keep a condition here. You will not simply like you will not do like 1992 or something like that. We will keep a condition. So the relation between the x1 column and the x2 column, if it is positive and if it is more than 95 percentage, then only select any one of the column between these two. Okay, because 95% of the relation are same. So these kind of operations you will be doing with the correlation. That is the purpose of correlation. Correlation is used to find the relation between the columns and also the strength, and also it is used to clean the columns. It is used to clean the columns, to remove the columns. For example, let's see how it will implement manually. Let's go with the Pearson correlation. First, I'm going to explain Pearson correlation. So let's take any one of the data, random data. Suppose if I'm taking 1, 4, 9, 7, 2, 6, and y. Okay, you need to understand the logic. I will implement on top of this data set, Titanic data set later. Okay, suppose 11 small values will take as We'll take very, very small values. Let's say 2, 4, 6, 9, 5, 3. Suppose this is an X and Y. I want to find out, I want to find out the relation between these two columns. The relation between these two columns is positive or negative. If it is positive, how much percentage? And if, is it more than 95 percentage or is it more than 85 percentage or not? To remove any one of the column. Three things I want to find out. So first thing, what is the Pearson correlation formula? Pearson correlation formula is what? So Pearson correlation formula is nothing but x minus x bar. Sorry, sorry. So the Pearson correlation formula is nothing but covariance of first column x comma y. X means first column, y means second column. Suppose in the place of a lot of people will confuse, I will write some other name. Suppose if I write here x1, x2, the column names. So covariance of x comma y means what? In the place of x, nothing but x1. In the place of y, nothing but x2. Okay. So just understand these two columns I am applying. So covariance of x comma y divided by standard deviation of x and standard deviation of y. So this is the general formula. This is the general formula. According to the column names, if you want to convert, according to the column names, if you want to convert, covariance of x1 comma x2 divided by standard deviation of x1 and standard deviation of x2. Okay. So how you will define this one? Numerator part. Covariance of x1 comma x2. So x1 minus x1 bar into y1 minus y1 bar. Yes or no, guys? Sorry. According to the here, according to the column name, x2 minus x2 bar. Yes or no?
Sir.
Divided by n minus 1. N minus 1 or n? I think what I have written here, n minus 1. Okay. Divided by n minus 1. And again you are having the denominator. If you write the denominator here, it will add to the here. So I'm writing. So let's say if you want to write only the mathematics, let me write divided by standard deviation of x1. So implement the concept each and every point in the x1 minus its mean x1 bar. Please find out x1 bar. Please find out x2 bar. Okay. So divided by standard deviation of x. What is the standard deviation of x formula? What is the standard deviation of x formula? So x1 minus its mean whole square divided by n minus 1 root of, yes or no, into multiplication into x2 minus x2 bar whole square divided by n minus 1 root of n minus 1 root of. So this is the complete formula. You need to implement on top of this data. So if you implement on top of this particular data, if you implement on top of this particular data, you will be getting a value. You will be getting a value. Suppose you got 0.2. Suppose you got 0.2. So based on this value, you can say, see the relation is positive relation between x1 column and x2 column, and the strength is 20% out of 100, 20%. And according to the condition, suppose if you keep the condition, the relationship between the two columns, if it is greater than 95% only, I will pick any one of the column, another column I can remove. But is it matching the criteria? 20% greater than 95%. No, it is not matching the criteria. So I will keep two columns as it is. I will keep two columns as it is. So if it is matching this, then any one of the column we can pick. Understood, guys, how the Pearson correlation works? So pure mathematics. So if we go here, let's say come to here. So you know we have the data already. You already have the numerical columns. You already have the you already have the numerical column. See, this is the numerical columns. So now I will implement. Now I will implement the correlation on top of these columns, which means first passenger ID with this one, passenger ID with this one, passenger ID with this one. So every column with the other column it will apply. So I have just CD with two columns. Same thing you implement for each and every column. So how to do it? So see, I'm going to apply on top of the numerical columns, on top of all these columns, I'm going to apply correlation. CORR. CORR means I'm going to apply correlation. So what you want to apply, guys? You want to apply Pearson or Spearman? I want to apply Pearson correlation. So method is equals to Pearson. Pure Pearson correlation mathematics is going to apply on top of this data. If I run it, see, can you see this? The correlations. See, the relation with me itself, the relation between the column itself with that column, it will be 100%. Survived with survived, it will be 100. P class with P class, it will be 100. Age with age, it will be 100, 100, 100, 100. So with itself, they will be 100. See, with survived column with P class, negative correlation. With age, negative correlation. So see, this is little bit positive. This is 20% positive, 20% positive. So a column with other column, you can find the relation. You can find the relation. So if you want to apply some kind of graphics for it, for this outcome, there is a concept known as a heat map. Heat map. There is a visualization known as a heat map. So which is used to represent correlation. Correlation in graphical manner. Okay, which is used to represent correlation in graphical manner. So I'm using C1 import this. C1 as SMS. Okay, C1 as SMS. So use in the C1, using C1, in the C1 there is a visualization. There is a visualization known as a heat map. There is in the C1, there is a visualization known as a heat map. So for this heat map, what we need to pass? You don't pass anything. You just pass all this outcome. So all this outcome you will get from this particular line. Yes or no? Yes or no, guys? Whatever the outcome that you are seeing, this outcome is coming from this particular line. So I'm copying that particular line and I'm going to paste it here. I'm going to paste it here. Simple. And I'm going to run it. I'm going to run it. You can see some kind of map. You can see some visualization here. Some visualization. But I will make it more attractive. What is the range of correlation, guys? What is the range of correlation? Tell me. The range of correlation is
minus infinity to infinity.
minus 1 to 1. Minus 1 to 1. Minus infinity to infinity is covariance.
Oh, yes.
So,
Minus
okay.
21.
This bar is there, no? This bar I will maintain from minus 1 to 1. This bar I will maintain from minus 1 to 1. So which means there is a parameter V minimum. V min is equals to minimum value minus 1, comma V maximum is equals to 1. So this bar is refers to V min. V min and V max, maintain them from minus 1 to 1. So this bar I am maintaining from minus 1 to 1. So see here, guys, the box which are having this particular color, or you can pick the value from here. For example, this is the box which belongs to P class and which belongs to fair. So what color this box is? This box color is something like this, no? Yes or no? So here, what is the value? Negative only, no?
Yes.
Negative value. So for example, see pure white. Pure white means which is coming from here, which is 100%. There itself, with itself, it will come 100%. So based on the color, you can check. Based on the color, you can check the columns. So you can do the visualization also. So sir, I want to represent the values on top of it. I want to represent the values on top of it. How? How is it possible? So you just
Label.
don't do any. Yes, label, but here it's a heat map. Here the parameter is anode. Just anode is equals to true. Anode is equals to true means please apply the values on top of it. See, you are getting the values. So by looking at these values, you can say What is the, by looking at the color, we will say, see, this is a positive, this is positive. So you can say survived column with P arch, it's positive. Survived with fair is positive. Let's say P class with SIBSP is positive. SIBSP with P class is positive. See, fair with survived is positive. See, the positive relations you can easily find out by looking at the graphical representation. So if you want to change the color, so I want to change this heat map color. So what you have to do, you need to go to the official documentation. In the C1, go to heat map official documentation. Go to, this is official documentation. Let's say see, it's a C1, completely official one. So there I will be selecting, I will be going into heat map. If you want to study, you can study about it. That's a different story. So CMap is there, no? CMap. Using this CMap, I can do lot of visualizations. For example, one of the famous one which I like, I will keep it here. So CMap means what color representation I want. I will keep tab 20. Tab 20 means one kind of color will come. See, this is one of the representation. So which is one of the representation. There will be one more thing like CREST, I think, or crest or crest, something will be there. The name might be, see, yeah, this is one of the visualization. So whatever the visualization that you want to show, whatever the visualization that you want to show, you can pick it here. How to select these names? Go to the official documentation. In the official documentation, if you come down, see, they will be giving here few names. They will be giving you few names here. For example, say CREST means this color. You can find out whatever the color you want. You can pick that CMap and you can give it here. You can give it here. Understood, guys? Correlation using the Pearson how we will do mathematics, how to implement.
Yes.
Concept, everything is same. Let's say concept -1 to 1, everything is same. Only the formula changes. Only the formula changes for Pearson correlation. What is the how the mathematics will be implemented for Pearson correlation? Let's see how the mathematics will be applied for the Pearson correlation. Sorry, we completed Pearson now. Spearman, right? Spearman. Okay. Spearman correlation. So how we are going to, what is the correlation range? -1 to 1. So what is just formula difference? Concept, everything is same. Spearman correlation formula is nothing but 1 minus 6 into summation of I is equals to 1 to n. I is equals to 1 to n di square divided by n into n square minus 1. N into n square minus 1. So formulas should be very, very important, guys. I'm telling you. N into n square minus 1. So let's solve this one. Okay. So what is the purpose of this one? What is the purpose of this particular concept? Okay. Imagine, let's say you have, for example, see, you have a column. Imagine you have, suppose I will write the name. Suppose you have the, let's say, a column name, suppose age. Suppose, let's say, fair. Just examples I'm taking. We have two columns, for example. Let's write the values 1, 4, 3, 7, 2, 9. Okay. Let's say 5, 4, 9, 2, 7, 6. Suppose these are the two columns. How the Spearman correlation works? If you want to implement the Spearman correlation, what you have to do is, the first one, what you have to do is, you need to sort, I'm writing the points here. Sort the first column. Sort first column. Okay. We need to sort the first column. First one. So this is the data I'm keeping like that only. This is the data I'm keeping like that only. So on top of this data, I will implement the concept. So first thing that what you have to do is, you need to sort the first column. Suppose age is the column. Please sort it. Please sort it. So what is the meaning of sorting in ascending order? In ascending order, you make it. So 1, 2, 3, 4, 7, 9. Okay, 7, 9. Next, fair. Fair. So when age is 1, its fair is 5. Yes or no, guys? 5. When age is 4, its value is also 4. When age is 3, its value is what? 9. When let's say, when age, sorry, when age
2
is
is
2, right?
related to 7,
Uh,
sir.
Year 2, 7, no? Sorry. Year 2, 7. So 4, 4 only, no? 4, 4. Next, 7, 2. 9, 2, 7, 9, 6, right? 9,
Yes, sir.
6. 9, 6. Okay. First point completed. So we converted the age into ascending order and its related values also will change, of course. Second point, give rank, give rank for each column. For the first column, each column is for the first column. What you have to do is we need to give the rank. We need to give the rank for each. What is the meaning of rank? Rank is nothing but in an ascending order, give the rank starting from 1. Starting from 1. So this is the rank number 1 for this particular value. This is the rank number 1, rank number 2, rank number 3, rank number 4, rank number 5, and rank number 6. Okay. So since the age column is in ascending order, we will just give the ranks like this. You can ask me, sir, here 7. No, why are you not writing 7? I am not replicating the value. I am just writing the ranks. Ranks means for every input which is in ascending order, I am giving the rank. Next, I will also give the rank for fair column. So see guys, in the fair column, according to ascending order, you need to give the rank. For example, smallest one is 2. So this will be the first rank. And next one, 4. 4 will be the second rank. Next, 5 will be the third rank. Next, 6. 6 will be the fourth rank. Next, 7, fifth rank. Yes, please tell me.
The 2 in the sense in rank of 2.
Sorry. What?
Oh, could you please explain from the first for the faith?
This is the
Rank
data.
of
What
faith.
rank of? See, I'm giving the rank for each column. Since it is already sorted in ascending order, for every value, if the value here might be 110 or 120 or 130, doesn't matter. So if it is in ascending order, the rank will be 1. So I'm giving in ascending, since the data in the age column is in ascending order, so I'm giving the rank. I'm giving the rank 1, 2, 3, 4, 5, 6. Okay. If I want to give the rank for fair, you maintain ascending order. So according to ascending order, 2 is the first one, yes or no? For the 2, I am giving the first rank. Next, for the
Here,
4, I am giving the second rank.
okay, sir.
Okay.
Hmm.
So next, we are getting age, fair, age rank, and this one. So these are the rules that we need to maintain. What is the third rule? What is the third rule? Find the difference between ranks. Find the difference between ranks. So we call them as DA. We call them as DA, difference between the ranks. 1 minus 3 minus 2, 2 minus 5 minus 3, 3 minus 6 minus 3, 4 minus 2, 2, 5 minus 1, 4, 6 minus 4, 2. This is the difference. Fourth one, square them. Square them. All 4 rules I am implementing. DA square, 2 square 4, 3 square 9, 3 square 9, 2 square 4, square 16, 2 square 4. Okay. So sum them. Sum. What is the sum of DA? 9 plus 4, 13, 13, 9, 22, 22, 4, 26, 26, 36, 42, 46 total. Yes or no? Total 46 I am getting. Total 46. This is the mathematics which is done on the back end. For Pearson rank, basically the name is Spearman rank correlation. The name is Spearman rank correlation. So now I will take this formula. What is the formula for it? 1 minus 6 into summation of I is equals to 1 to n di square divided by n into n square minus 1. Where is the stable formula? If you want to find out why this 6 is coming, why this formula is writing like this only, you need to do R&D in the statistics. It takes around 12 to 15 years. Okay. So we are going to implement the direct formulas here. So 1 minus 6 into summation of di square. So this piece already done. Yes or no, guys? This piece already done. Yes or no? I
Yes,
find
sir.
out that the di square and I am summing it. I got 46 divided by n means what? Number of rows. How many are there? Total 1, 2, 3, 4, 5, 6. 6 into 6 square minus 1, 36 minus 1. So you please solve this issue, solve this particular mathematics. 46 6 are 6 are 36, 6 4 are 24, 27. 276 divided by 6 into 35. So 5 6 are 30, uh, 6 3 is 18 and 210. So 210. So 210 minus 276 divided by 210. So whatever the value you got, suppose if you are getting a negative value means it's a negative relation, positive means positive relation, zero means zero, no relation. Simple. Zero means no relation. Simple mathematics will be changes, remaining everything is same. If I go back to the coding here, for example, see same thing I will do, same thing I will take. I have the numerical columns. I am going to apply the correlation and now I want to apply Spearman. Spearman. Just I am going to change the mathematics. That's it. This is the Spearman correlation values. Spearman correlation values. Suppose if you want to see the difference, keep anything. Suppose this value I want to see. So 0.013 is for passenger ID and the fare column. For the fare, first one 0.013. If I changes to Spearman, if I changes to Spearman, let's see the value is changing or not. See, it is minus 0.014. Okay, because mathematics changing, value will be changed. Okay, so which one you want to use, you can use it. So why this all the rules we are following for Spearman rank correlation? Why all the rules we are following? So let's go to the internet. In the internet, Spearman rank correlation, for example, Spearman rank correlation. If you go to the official Wikipedia page or any of the written blogs by other tech platforms, other blogs or anything. Let's say if I go to the Wikipedia page, which is an official one, if you come down, see they are taking two different columns. They are taking two different columns. For example, see what they are telling. They are telling to sort the first column. So this data will be sorted. While sorting, see 97 will comes first. Its related value 20 will be here. Its related value see 20 will be here. 86, its related value 2 will be here. So first I'm doing the sort of this one. Its related value I'm mentioning. I'm giving the rank. For this also I will give the rank. Difference between the rank I will get. I will square it. I will submit. Same concept which is mentioned in the Wikipedia page. So if I explain here, it will be more complicated for you to understand all these formulas and everything. So I simplified into pure mathematics, which is in understandable way. So this is completely about inferential statistics, correlations and covariances, all the mathematics and pure implementation here. Clear, guys? Any doubts? So generate code with the numerical. Let's see what AI is giving. What AI is giving for me. Let me see this. So let's see AI features integrated. Okay. Automatically AI is giving all the things. See, I didn't try all these things in recent days. See, it is giving all the things, all the visualizations. Okay. Very good. Because Google Colab is completely integrated AI. So see, integrated a lot of things, a lot of work is very much easy for us. See, if you want to generate the next code automatically, once you load the data, you divided the data only numerical data. So your AI artificial intelligence will understand what to do in the next step. So it will generate the code. Suggest a plot. For example, if I want to apply box plot, if I want to apply box plot, let's see whether it will give or not. So beauty, right? It will taking input and AI is generating everything. So see, so this input, whatever I am passing, will be sent to the model, and by model, it will train itself from the data within nanoseconds, and it will give the outcomes. Guys, clear till here? Any doubts? Okay, guys. Okay, so in the next sections, like I will check is there any stats concepts. I think okay, there are concepts like hypothesis kind of concepts we'll discuss in ML part. So we'll start SQL. So installations of SQL, all the things. Okay, in the next sections. Clear now, guys? Still here? Any doubts?
Sir, till
Yes,
here
please.
we understand, sir, but what the thing is, how we need practice because
Yes,
uh,
yes, please. Yes, please tell me.
అంటే ఒక ఒక దాంట్లో ఉన్న నేమింగ్ ఇంకొక దాంట్లో ఉండట్లేదు కదా. వీ నీడ్ టు అండర్స్టాండ్ అండ్ రిమెంబర్ దోస్ ఆల్ థింగ్స్. వీ నీడ్ టైమ్ టు ప్రాక్టీస్.
చేయాలి ప్రాక్టీస్ చేయాలి. ఓకే, got it, I understood. Okay. Okay, so what's the
ఇదంతా
record?
పాసిబులేనా సార్? అంటే ఇంత వర్క్ చేయడానికి పాసిబిలిటీ ఉంటదంటారా? అది నేను
ఇది అసలు ఇక్కడ ఇంకా అసలు సబ్జెక్ట్ ఏం స్టార్ట్ కాలేదు కదా. సి వాట్ ఐమ్ సేయింగ్ ఇస్ జస్ట్ బేసిక్స్ అన్ని. ఏది పైథన్, ఇఫ్
ఓకే.
యూ సే ఇట్స్ జస్ట్ మీరు పైథన్ ఒకటే నేర్చుకున్నారు, జస్ట్ స్టాట్స్ బేసిక్ ఇంప్లిమెంట్ చేస్తున్నారు. ఇంకా మీరు అనాలిసిస్ కదా, సో మీకు వర్క్ తక్కువనే ఉంటుంది. మెయిన్లీ ఇంకా మనం మెషిన్ లెర్నింగ్ అయి చూసుకుంటే అది ఇంకా బాగుంటుంది. మెషిన్ లెర్నింగ్ కానీ డీప్ లెర్నింగ్ కానీ. సి వాట్ ఐమ్ సేయింగ్ ఇస్ వర్క్ ఉంటుంది, వర్క్ ఇంట్రెస్టెడ్ గా ఉంటుంది, చాలా బాగుంటుంది అది. ఇది బేసిక్
అవును
థింగ్స్ అన్ని.
కదా. పవర్ బిఐకి వెళ్ళేసరికి అది వర్క్ చేసినట్టు కాకుండా కొంచెం గేమింగ్ అన్నట్టు ఉంటది. డ్రాగ్ అండ్ డ్రాప్స్ అంటే డాక్స్. ఈ దాంట్లో కూడా ఇప్పుడు ఏఏ ఇన్బిల్ట్ ఏదో సమ్ ఫంక్షన్ ఏదో వచ్చింది కదా, అక్కడ డాక్స్ నాకు ఈ టైప్ లో కావాలి అని మనం మెన్షన్ చేస్తే అదే డాక్స్ ఇస్తుంది ఇన్ రియల్ టైం.
ఎస్ ఎస్ ఆఫ్ కోర్స్.
అది ఇది కూడా నేర్చుకోవాలి, ఇది కూడా ఇంప్లిమెంట్ చేయాలి అని అనుకుంటే, బట్ ఇట్స్ టేకింగ్ మోర్ టైమ్ ఐ థింక్ సో.
ఓకే, ఉంటుంది. పైథాన్ ఇంపార్టెంట్, అన్ని ఇంపార్టెంట్, బట్ ఇవన్నీ బేసిక్స్. ఇప్పుడు లెట్స్ సే అంటే పైథాన్ అనేది ఎలా ఉంటుంది అంటే, ద పీపుల్ హూ ఆర్ ఓన్లీ టు లెర్న్ డేటా అనలిస్ట్ వాళ్ళకి ఇలానే ఉంటుంది పైథాన్ అనేది. జస్ట్ స్మాల్ గట్టిగా 3-4 లైన్స్ రాయడం, జస్ట్ విజువలైజేషన్ చూపడం ఎట్లా. బట్ ద పీపుల్ హూ బిలాంగ్స్ టు ద డేటా సైంటిస్ట్ అంటే మెషిన్ లెర్నింగ్, డీప్ లెర్నింగ్ వాళ్ళది ఇప్పుడు ఫర్ ఎగ్జాంపుల్ సి ద రోల్స్ కి రెస్పెక్ట్ ఎందుకు ఉంటుంది, హై ప్రయారిటీస్ ఎందుకు ఉంటాయి అంటే, లెట్స్ యూ క్యాన్ సీ హియర్ ఏ డేటా అనలిస్ట్ can understand the data or visualize the data, but he can't do all these operations. Yes or no?
ఎస్.
ఇక్కడ మీరు జస్ట్ ఆన్ చేయగానే మీకు ఇమేజెస్ వస్తున్నాయంటే ఇట్స్ కంప్లీట్లీ బికాస్ ఆఫ్ డేటా సైంటిస్ట్. ఓకే, సో ఇలాంటి అడ్వాన్స్ లెవెల్ నేర్చుకోవాలంటే మాత్రం కొంచెం కూర్చొని నేర్చుకోవాలి. ఓకే, టైం పడుతుంది.
ఓకే.
Web scraping is another thing. Like web scraping means we'll scrap the data from internet. That we'll see in the last. Rahul, in interviews where interviewer asking all these formulas, definitely they will ask the formulas. Priyanka is asking, but in real time also we have to do both or either. No, in the real time, see, in the real time how you will do, first you will find the outliers, whether in a column outliers is there or not. If there is any outliers, you will handle them.
In
Okay.
real time also, sir.
Yes, of course. If there is
Okay.
outliers, you need to handle them.
Okay, sir.
Yeah.
Okay, sir.
Okay. Okay, guys. You just find out all these files in your drive, both the drives. Okay. I don't know whether the sections will be there or not tomorrow festival. So our management will be updating you. See.
Thank you, sir.
Okay. Okay. Bye bye.
Yes, sir. Bye.